Hi folks, I guess we are live. Let me just check if everything is working as expected. Just give me a minute just to see things are working all right. Okay, so, okay. Again, please confirm in the chat window if everybody is able to hear me clearly. Yeah, I can hear myself playing back. So please confirm if everybody is able to hear what I'm and everybody can see my screen being shared. If that's the case, I think we are doing good. Okay, so hey folks, thank you for joining in. Since we are a few minutes early, let's wait for everyone to join in. And yeah, thank you for the confirmation. Thanks that everybody can hear and see, hear my voice and see my screen. So any questions? I can take a couple of questions before the live session itself starts. I'll try to do my best. Okay, thank you folks. Thank you for the confirmation that I'm both, my screen is visible and my audio is audible. Sounds good. We're doing good. Okay, we'll get started in a few minutes. So any questions, do let me know. I'll try to answer a couple of them before we jump into the live session itself. So one thing that I've done is the dynamic programming problem that we were solving yesterday. I rewrote the code just to make it much more easier to understand. I'll explain. Instead of using an external code resource, I thought it's best if I just write the code myself in a much more simplified format. Of course, it's less optimal, but easier to understand. How often do we get data in SQL form in the real world? Again, you do get it a few times. In machine learning, what happens is most companies, right? If you're working in a large company, let me tell from my own experience. At companies like Amazon, Yahoo Labs, etc., these companies store enormous amounts of data, right? So this data is, again, depending on the data store, this data could be stored in a standard relational database like an Oracle DB or a MySQL DB, or it could be stored on a Hadoop cluster or a Spark cluster, right? So a Spark cluster. So again, if it's stored in a traditional relational DB or even some non-relational, non-SQL based DBs, most of them have SQL interface, even if it is stored in a data warehouse, right? So it's either a traditional relational database or a data warehouse. Most databases and warehouses have an SQL interface. Similarly, if you are using Hadoop or Spark, right? Hadoop has something called as Hive, which is very close to SQL. Similarly, Spark has something called as Spark SQL, right? Even for big data technologies, SQL is super important because most of the querying languages that are used, even on big data platforms, even when you have petabyte scale datasets, is a small modification on SQL. So again, depending on the application, it's very common to come across SQL based interfaces to data, either traditional databases, data warehouses, or big data stores, right? So sounds good. So yeah, somebody is saying, Ritvik, it's a good question that you asked. Till date, everyone who completed the course in Applied AI course have got at least one job. Many of them have got multiple jobs, and some of them joined in a job right after the course, and then they switched jobs 6 months later. So this is a good part till now. Okay, till now, everyone who completed all the assignments on time for Applied AI course, we have been successfully able to place them at least in one job, in many cases more than one job. Okay, so somebody says, which one is better to learn, SQL or MongoDB? I think you should first learn SQL, then you should think of other. SQL is a very simple thing, and SQL is an extremely generic, powerful system with which you can query lots of data stores. Don't go for this fancy stuff. Again, there is this tendency amongst youngsters, even experienced folks sometimes, to go behind fancy stuff. If your fundamentals are not strong, however fancy technologies you learn, you're not going to succeed. So before you learn MongoDB or any other NoSQL database, again, these are phenomenal data stores. They have their own place. They're extremely useful in some instances. But if you don't know SQL, I think you should first learn SQL before you go and learn other complex technologies, right? Sounds good. Somebody is asking how to compute out-of-bag score in random forest regressor. Again, this will take me at least half an hour to explain in this context. Probably we should do it when we discuss random forests themselves. So any good book for probability and statistics as a subject has this fundamental problem, which is there are either, so for probability and stats, you'll come across two types of books. You'll come across one set of books that are very strong on theory, other set of books that are very strong on practical. It's very hard to find something that does a good job, right? Your standard textbooks at undergraduate level cover theory very well, but it's all theory, right? You don't know how to connect it to practical applications. One book that I really like from a practical aspect, because I learned a lot of theory in college, but one book that really helped me connect theory to practical stuff is this book called Think Stats. It's a very nice book. I really like that book. I've Think Stats. So Think Stats is a simple book. Oh, it's also available in PDF, freely available. You can download it. What I like about this book is this book teaches you the basic concepts of probability and statistics using some real world examples. Okay, whether it's distributions, densities, all the concepts. It's a very nice book actually. So if you want to learn from a practical standpoint, Think Stats is one of my favorite books. But the theory in it is slightly on the weaker side, but that's okay. For applied stuff, you should also learn. Again, I've seen a lot of people who can derive things, but who can't connect it to real world. So this has always been one of my favorite books. It's a slightly old book, but again, probability doesn't change every now and then, right? It's been the same for a few decades now. Of course, there are some advances, but the foundations are the same. So this is one of my favorite books. Okay, sounds good. I think, let's see. Okay, I think it's already 2 minutes past 6. What should we do if you're stuck with a concept? Somebody says, suggest a book for data structures algorithms. I think that's important. So CLRS, this is the best book that I know of for data structures algorithms in general. Just Google search CLRS. I mean, this is okay. Don't type CLRS code Python. Just type CLRS. You'll get this book called Introduction to Algorithms. This is the standard textbook at most universities of the world. And this book might feel a little theoretical, but the way they cover the concepts, I told you in yesterday's live session also, this has been a book that I've used since my second year, first semester at undergraduate level. I have the same copy. I've rewritten. I mean, this has been, again, when I taught the data structures algorithms course for GATE computer science students, and also for our interview prep course, I covered everything from this book, because I think this book is one of the best, at least because I learned from it. Of course, I'm biased. I've read other books also over the course of time, but this has always been the best book that I've seen for somebody who is a beginner level. If you're an advanced level guy, there are other books which are good. But for a beginner level, I think Introduction to Algorithms, CLRS, it's called CLRS because Corman, Leeserson, Rivest, and Stein, 4 computer scientists, right? I mean, it's a terrific book. I mean, if I have to pick one book in whole of algorithms, data structures, this will be it. Sounds good, guys. So let's get into it. Let's get into the whole live session where we stopped yesterday. I'll continue from there. Again, I'm changing the code, dynamic programming problem that we saw. When I was rethinking about it, I felt that the code that I suggested yesterday, I think I'll have it here, right? So 1 second, let me just open that for you. Code walkthroughs, okay. So yesterday we were looking at a different code, right? So yesterday I was telling you, so I told you about this overlapping subproblem, all of that. And I was trying to show you a dynamic programming with this type of diagram. Again, this code I showed you that I borrowed it from LeetCode. But then when I realized that this explanation is slightly on the more complex side, again, since many of you may not be very comfortable with dynamic programming, I thought I'll rewrite this using the previous code that we saw, right? So yesterday we saw a simple recursive code, right? We saw the recursive code. I explained it step by step. I'll modify this code using dynamic programming now, right? I think that will be easier for everyone to understand, right? So let's go through that. Okay. So, okay, where is our, okay. So today the agenda is simple and straightforward. Again, I'm sorry I complicated the dynamic programming slightly yesterday. I'll simplify it now. So the focus is the dynamic programming example that we were solving yesterday. We'll complete that. Then one of the big questions in most programming is which data structure to use when. Again, this is a very, very important question because you'll come across lots of, there are basically a bunch of data structures, right? You have list, tuple, dict, set, and strings. We've already seen strings. Strings are easy to understand, right? We have seen strings and regexes till yesterday. There are 4 other very important data structures which are inbuilt in Python. Now, which data structure to use where, right? So that's a very important question. So what I'll do today is I'll complete the dynamic programming example and we'll see which data structure to use where. I'm assuming that you have gone through the previous code sessions till now and you have basic knowledge of inbuilt data structures. I'm going to assume that, right? If you do not have that, again, I'm giving you the documentation from Python itself. This is Python version 3 documentation. There is a very nice tutorial on all these data structures. If you don't know, this tutorial is very good. It explains a lot of details. Of course, there are also some nice tutorials on Geeks for Geeks. Okay, sounds good. With that, let's get started. Where were we yesterday? Okay, this was the regex matching problem that we were solving, right? Very clear. Question mark matches single character, star matches 0 or more characters. We saw this. What did we do? We wrote a simple recursive algorithm. Okay, this is fairly clean algorithm. If you notice how many lines of code it has, let's ignore the prints and let's ignore the print statements. Let's ignore the comments. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's literally under 15 lines of code. Again, I've shown you how this works, but I've also explained it to you that this code, I've shown it to you yesterday that this code has an exponential time complexity, right? And again, that's very simple because if you look at it in the worst case, again, when you're computing time complexity, you have to always think about the worst case, right? In the worst case, if you notice this code snippet here, in the worst case, a problem of size n, let's assume these two are same size n or similar size n, can be broken down into 2 problems of size n minus 1, right? So what happens? Your recursive equation looks like this. Okay, your recursive equation looks like that. A problem of time taken to solve a problem of size n is time taken to solve a problem of size n minus 1 into 2, right? Because you have to solve 2 problems plus order of 1 because you have to compute the logical OR, right? And using the recursion tree approach, again, there are many strategies to solve this recursive equation. Recursion tree is one of the simplest. Again, we discussed this in our course videos also. So using this approach, we saw that the simple code that we wrote has exponential time complexity, which is always bad, right? Which is not at all good. So then I said, okay, how can we improve it, right? So what I've shown you is, imagine if I have my pattern and string, my pattern has, let's say, n characters. Let's say my string also has n characters. I drew the recursion tree here, right? And I've shown you that there is overlapping subproblem. What is, again, first and foremost, we have seen that this problem can be solved using recursion. That's very important. And I've shown you with this example yesterday, again, a problem where P has n characters, S has n characters. If you, in the worst case, let's write the worst case. In the worst case, this is your recursion tree. This problem will get solved if you solve this problem and this problem, right? This problem you can solve if you solve this problem and this problem. This problem you can solve if you solve this problem and this problem. First thing you'll notice here very easily is the same subproblem here is being solved twice. Once when you're solving this subproblem, you have to solve this. Again, this will get broken down into into smaller parts, right? So what it has is something called as overlapping subproblem. Why is it called overlapping subproblem? Because the same subproblem you're solving over and over again, right? When you see a structure like this, when your solution is a recursive solution with overlapping subproblem, this should tell you that you can solve this problem using dynamic programming. Again, dynamic programming is one of the very, very popular ideas in algorithmic design. And this is one of the most favorite concepts that people ask in product-based company SDE interviews, right? In software development roles. Again, if you interview at Amazon, Facebook, all of these top product-based companies, it's very likely that you'll encounter at least one dynamic programming problem. And how do you recognize the problem is dynamic programming? First, you have to recognize that it is recursive. And by just drawing this tree, you can recognize that it is overlapping subproblem. The moment you recognize both of them, again, this is often not asked for, again, if you're a machine learning engineer or a data scientist or a machine learning scientist at product-based companies, problems like this are asked if you have prior experience in software engineering or if you come from computer science background, right? So I thought I'll cover this for the interest of people. Again, if you're not a CS guy, if you're not a computer science guy, if you don't have prior experience, then even if you write this code, you're more than good. Again, every programmer, everybody who's applying for machine learning roles, the expectation is that you can write recursive code. Let's not miss that point. Recursion is mandatory. Dynamic programming is not mandatory. But again, it's not rocket science. Okay, so first and foremost, when you have overlapping subproblem, the idea is very simple. The idea is very simple. Whenever I'm solving a problem, why don't I store the problem that I've already solved? For example, look at this. Let me show you with this example, right? So for example, let's assume I'm solving this problem. While solving this problem, let's assume first I solve this problem. When I solve this problem, let's assume first I solve this problem, then I solve this problem. When I solve this problem, okay, what if I store the result? Again, solving a problem basically means I have to determine whether it is true or false, right? In our case, whatever is the result of it, if I store it somewhere, if I store this result somewhere, next time what happens? After I solve, again, look at the sequence. To solve this problem, first I solve this. To solve this, I solve this. There are again bunch of subproblems here that I'll have to solve. Then I solve this. Then I want to solve this, which is 4. To solve this, again, I have to solve this, right? And I have to solve this. This is 4. This is the 5th subproblem. This is the 6th subproblem. To solve this now, because I've already solved the same problem earlier and I've stored the result, I can just fetch this result without again calling the recursive function and again. So the whole idea of memoization, okay, the whole idea of memoization is if you have solved a subproblem once, just store that result somewhere so that if you have to solve the same subproblem again, instead of again calling recursive function, just get it from the store. Right? That's it. That's a very simple commonsensical idea. That's the whole idea behind dynamic programming, right? So the whole idea here is, why don't we store solutions that we have already computed, already solved stuff, let's store it somewhere. One way to store it, again, there are many ways of storing it. One way to store it is in a data structure like a dictionary. Again, a dictionary, I'm assuming that you know the basics of Python here. A dictionary is like a hash table, right? It has key value pairs, right? It has key value pairs. And if you search, again, what is one of the properties of hash table? You can, given a key, you can find the value and you can search it very fast. This is a fundamental property of dictionary, right? Dictionaries, you can search very, very efficiently in order of one time. That's the most beautiful property of a dictionary. That's what they're most used for. Again, in the real world, if you ever become a software engineer or if you are a software engineer, dicts or hash tables, again, Python calls them dictionaries. The standard terminology in data structures algorithms is hash tables. Dictionary is nothing but an implementation of hash table in Python. That's all it is. Hash tables are the most widely used of all the code that I've seen in my life in production. Hash tables are the most widely used data structures in the industry because they're extremely powerful to search based on the key value in just order of one time. Again, the mathematics behind hash tables is beautiful, but it's much beyond the scope of this discussion. Okay. So what is dynamic programming? It is basically if you have recursion and overlapping subproblem. That's it. And again, as I mentioned yesterday, we will, in our course, in our applied AI course, we have covered this concept when we learn backpropagation and deep learning, right? So you'll again see that when we go to backpropagation. Okay. So now, again, let me give you one more concept here. Okay. So dynamic programming can be solved two ways in general. Given any dynamic programming, we can solve it using something called as top-down dynamic programming or bottom-up dynamic programming. Okay, there are two ways, right? There are two ways. Both of them have their own advantages and disadvantages. Yesterday, the code that I wrote or that I showed you from lead code is actually a bottom-up DP. Again, a top-down DP basically means that I'm going to still use recursion. I'm going to use recursion plus I'm going to use some storage to store my subproblem solutions. Bottom-up DP says instead of using recursion, because recursion has some disadvantages, I'm going to use iteration, right? And I'm going to use table and so this is also called as tabulation methods. So bottom-up DP in some textbooks, it's also called as dynamic programming by tabulation. Top-down DP in some textbooks is also called as dynamic programming using memoization, right? Or it's also called as memoization based dynamic programming. So yesterday the code that I showed you, which I was trying to explain with that with the table, is bottom up. Again, the biggest disadvantage with bottom up DP is it is harder to understand. It is slightly harder to understand, but it is computationally slightly more efficient. Top down DP is easier to understand, slightly less computationally efficient. So instead of using bottom up, because some of you are beginners in this, I thought, why don't we just use top down DP, because it is easier to understand. So I've written the code using top down DP. So if you recall this code, what I've done actually, okay, let me go to this, okay. So what I've done is, this is the code that we saw yesterday, right? So I just modified this code slightly, okay. Again, this is recursive. We saw this recursion, right? I just modified it slightly today. Now let me explain how this works, okay. Let me go step by step, okay. I'm calling this function isMatchDP, okay. I'm isMatch using dynamic programming. The idea is this. So whenever I solve a subproblem, okay, look at this diagram here. Look at this diagram here. Whenever I solve the key idea is this. Whenever I solve a subproblem, imagine if I solve a subproblem like this. Imagine if I solve a subproblem like this. How do I store this data? If you notice, the starting index itself is changing. The ending index stays the same. The ending index always stays the same in each of the subproblems. You can draw the subproblems. The ending index doesn't change. It's the only starting index that changes. So what I'll do now is, let's call this as p start or pattern start, and let's call this as string start. Okay, let me call them as pattern start, which basically means pattern start index and string start index. Sorry, string start index. Right? So again, I have to store this information, right? I have to store, suppose for example, if I solve this subproblem and the result of this subproblem is, let's say, true. Let's just say the result of this subproblem is true. After I've solved it, I want to store it somewhere. How do I store it? One data structure that I can use here is a dictionary. So how will I design my dictionary? A dictionary has key value pairs, right? A dictionary looks like this, right? A dictionary has key value, key value, key value, key value, etc. Right? So you have a key and you have a value. This is how dictionary looks like, right? So what do we store in the key? The key should be this index comma this index. So I'm storing the result of this subproblem in a dictionary. I'm naming this dictionary as DP. Okay, DP. Small dp means it's the name of the dictionary. In this dictionary, my key is basically a tuple. And what is the first entry in the tuple? The first entry is the pattern start. The second entry is the string start. And what is the value in this dictionary? The value is the solution, true or false. Right? This is what I'm storing in my dictionary. Now, if let's assume I solve this problem, how do I store this in my dictionary? I'll say in my dictionary, I'll create an entry 2,2 and I'll say the value for this is true. And of course, there could be other entries also. Right? There could be other entries also. Right? This is how I'm storing in my dictionary. Now, when I'm storing this in my dictionary, when I have to solve the problem again, right? Look at this. I've already solved this subproblem. So I've stored the result in my dictionary DP. Now, if the same problem, if the same problem has to be solved again, before I solve this problem recursively, first I'll check if my dictionary contains this entry 2,2. If it contains this entry 2,2, if I already have the result for it, I don't have to again recursively solve this problem. Right? Very simple. And again, why am I using a dictionary here and not some other data structure? Because in a dictionary, if I'm given the pattern start and string start indices, if I'm just given these two indices, I can quickly search in my dictionary. Again, remember in dictionary, if you give a key, you can search in order of one time. This is one of the most important properties of a dictionary or a hash table. Again, that's what we are going to use now, right? So let me go into the code and explain you the code line by line. Okay, so my recursive function, I'm changing it slightly. My input is pattern, string, the pattern start, the string start, and the data structure DP. Again, what is DP here? DP is a dictionary. Pattern start basically means if I'm solving a subproblem with my pattern, given that I'm a pattern, let's say from 2 to end, if I want to match 2 to end, and let's say string if I want to match 3 to end. This is the pattern that I want to match with this string. Then the pattern start will be 2, the string start will be 3. Right? So basically these two tell me from which index in the pattern to the end should I match with from which index in the string to end should I match it with, right? Again, it takes a couple of minutes to get used to it. But then rest of code is very simple. Look at what I'm doing here. I'm saying if pattern start comma string start, if it is already there, look at this. What am I doing first? This is very important. Let me use a different color. Let me use red color. First, given the pattern start index and the string start index, I'm creating a tuple here. Look at this. I'm creating a tuple here. Using this tuple, I'm saying, is this tuple present in my DP? What does this syntax tell me? This syntax says, is suppose if I got 2, 2. Okay, I got my pattern, I got my whole string, I got 2. Let's assume I got a dictionary here. Now what it says, first thing that I'm checking here is have I already solved a problem where I'm taking the pattern from the second index, the string from the second index? Have I already solved it? If I've solved it, I would have stored the result in my dictionary. Again, remember that DP is a dictionary. I would have stored it in my dictionary, right? So first thing that I check before I even go into recursion is, have I already solved this problem earlier? So this is the syntax for it, right? How do you check, given a key, how do you check its presence in a dictionary? This is how you do it. If it is already present, just return that. Again, what does this syntax tell you? This syntax will tell you, again, remember that I'm constructing a tuple using pattern start and string start. Because my key, remember, in my dictionary, my key is my pattern start and string start. My pattern start and string start. My value is the solution to that subproblem, either true or false. And how do I get the value given a key? This is the syntax, right? In dictionaries. Again, I'm assuming that you know the basics of dictionaries, you know the basics of lists, tuples, etc. If you don't know, please go and read from the resource that I just mentioned at the start of this discussion. Okay, cool. If this is there, I'm done. I'm not even calling recursion now. Right? If I've already pre-solved the question, if I already solved this same problem earlier in my overlapping subproblems, look at this. If I've already solved this problem and if I've stored this solution in a dictionary, I don't again have to solve it. And that's the beauty of DP, right? That's the whole idea of DP. Otherwise, if that is not the case, what am I doing? I'm just saying my pattern and string that I want to match now is my pattern from the pattern start index, my string start index. Again, this whole code, if you notice, this whole code is very similar. All these cases that we have written here, look at this, all these cases that we have written here are exactly the same as this code snippet. Actually, I've modified this code only. Look at this, all these cases that we discussed yesterday, same cases we have here. If P equals to S, if P equals to star, if P equals to empty or S equals to empty, if P0 equals to S0 or P0 equals to star, if P0 is star, if P0 not equals to S0. Same cases, no? All these cases we discussed yesterday. So the recursion part more or less stays the same. These are the boundary cases, these 3 plus this. These are 4 boundary cases and 2 recursion cases that we saw yesterday. Same thing. Here also, the only difference between yesterday's solution and a dynamic programming solution is whenever we compute any result, we should store it in our dictionary. And before calling recursion, I'm going to first check in my dictionary if I've already solved the problem or not. Otherwise, this whole thing is the same. And remember, unlike yesterday, look at this code, look at this snippet of code. The only difference now is, look at this snippet of code and this snippet of code. Yesterday, what did we do? If P equals to S, just return true. We are not storing it anywhere in yesterday's solution. In a simple recursion based solution. In DP based solution, whenever you come up with a solution, you should store it in your dictionary. So before you return anything, this step basically stores the result in our dictionary, which is DP. Right? Similarly, before you return, you should store it in a dictionary. Whenever you compute a solution, you should store it in the dictionary. Again, here also, you're calling isMatch DP, which means you have solved this problem, that whatever is the solution, you should store it first. Whatever is the solution, you should store it first. Whatever is the solution, you store it first. So the only difference between this dynamic programming based recursive solution or memoization based recursive solution and the simple recursive solution that we saw yesterday is very simple. The only difference here is we are using a dictionary to store all subproblems that we have solved, right? And before we go into recursion, first we check if the subproblem has been solved. If it is solved, we just return that. And before we return anything, we store the results in our dictionary and we pass our dictionary also. Very simple. Again, this is our, again, if you look at this code, actually it took me like 5 minutes to modify this code into this code. If you are careful, you can do it in like probably even less than 5 minutes. Again, I'm not attending interviews nowadays, so I'm not very comfortable writing this code, but it shouldn't take you, like if you know the concept of DP, if you have recognized overlapping subproblem, this should not take you more than maximum 10 minutes. Even if you're a beginner, it should not take you more than 10 minutes because the logic is simple, right? You should first always check if you have already solved it, and then whenever you solve a problem, just store it in the dictionary. That's it. It's very simple. So it will take you like first you can write the recursive solution, argue that it is exponential time complexity, observe overlapping subproblem, argue that it is order of 2 power n time complexity, show that it has overlapping subproblem. Because it has overlapping subproblem, you say I'm going to use dynamic programming and I'm going to use a recursion based dynamic programming, and let's test it. Is match DP, if you test it, it works. Again, remember, I have to pass a dictionary, right? Look at this. What are all the parameters? How do I solve this? This is my pattern. This is my string. I want to start, when I call it the first time, right? I want this whole pattern to be matched with this whole string. That's why my pattern start index is 0. My string start index is also 0. And initially my dictionary is empty. Initially my dictionary is empty. That's how you call this function. That's very important, right? Again, it works in all the cases. Okay, same. Again, I'm printing just like yesterday's cases. All the cases. The important thing here is you have to pass this. Because what is happening here? All this whole string, I want to match it from index 0. This whole pattern, I want to match from index 0. This whole string, I want to match from index 0. And I'm passing a dictionary which is empty at the very beginning. Beginning, it should be empty, right? Obviously. Again, I have a bunch of cases just to test if everything is working. It's working fairly well. Now, interestingly, the dynamic programming problem that we solved is often called as a two-dimensional dynamic programming problem. Why is it called two-dimensional dynamic programming? Because we have, look at this. Look at how our problem is, how our problem works, right? Your pattern and string are fixed here. There are two variables that are changing as part of your recursion. There is pattern start that is changing. There is string start that is changing in your recursion, right? There are two variables. Even if you just see this, even if you see this, there are two in the recursive call. Look at this. In the recursive call, these two values, this value increased by 1, this value stayed the same. In this case, this value stayed the same, this value increased. The end values don't matter actually. The end values actually don't matter. I just drew this diagram with end values so that it will be easier for you to understand. The end values are always n, right? But if you notice, there are two variables here. There are two variables that are changing in your recursion. Unlike this, if you look at your standard Fibonacci or look at factorial, that's a simpler one, right? How does your factorial function work? Your factorial n, right? Again, I'm writing pseudocode here. If n equals to 1, return 1, right? Return 1, else return n into factorial of n minus 1, right? This is the pseudocode, right? Again, remember, in this code snippet, you only have one value that is changing. This value is changing from n to n minus 1. So this is often called as a one-dimensional DP because there is only one variable that is changing as you go from a larger problem to a smaller problem. The two-dimensional dynamic programming basically is, in our case, the length of the pattern, right? The pattern start and the string start. Both, there are two variables, and as I keep solving the subproblems, both of these will change. Both of them will change, right? Because there are two variables that are changing as part of your recursion. This is what is called as a two-dimensional DP. This is what is called as a one-dimensional DP. Again, I did not want to introduce the concept of dynamic programming from a theoretical standpoint. That's why I've taken this simple problem involving regexes. Again, we remember that regexes is a very, very important tool for machine learning. right? Or for data science, or even for any text processing. For any text processing, regexes are important. And within regexes internally use dynamic programming extensively, right? I wanted to introduce this concept from a more real world perspective instead of just giving you some toy problem which doesn't correlate with reality, right? Again, if dynamic programming is, if you are interviewing for software development engineer roles at product-based companies, DPs or dynamic programming is super duper important. If you are interviewing for machine learning roles, not so important, but if you have prior software engineer experience, or if you come from computer science background, top product-based companies expect you to write dynamic programming. Again, only top product-based companies, right? Even there are some companies, there are some very good startups which are saying, okay, let's not do dynamic programming every time. Okay, sounds good. But if you want to learn, again, here is a very nice blog from Geeks for Geeks on how to think about solving dynamic programming problems. And there are 50 practice problems. Again, if you just go here, there are 50 problems in this. I really like this list. Okay, so, okay, we can always go back. Okay, there is a list, and for each of them, there is a solution given in some other blog with some nice explanation. Again, there is code in C++, Java, but you can always Google for it. You can say longest common subsequence, Python code, you'll get it, right? So those of you who want to practice more dynamic programming, this is the strategy. But remember, the dynamic programming is all about recursion. If you can break a given problem into recursion, and if you can recognize overlapping subproblems, that's it. You can solve dynamic programming problems very easily. That's all. This is the crux. Again, even within this, recognizing overlapping subproblem is easy. Breaking the problem into recursion often is the most time taking. Right? That's why actually even in a lot of interviews for non-CSC people also, people give recursion programs, especially at product-based companies, to see how they're thinking from a recursion standpoint. Okay, so with that out of our way, let's go to Python's inbuilt data structures, right? Okay, I'm making some assumptions. Now let's make it interactive, right? So any questions? Can we solve factorial problem using DP? Again, you can just solve it instead of DP, right? You can just solve it using iteration, right? And make it very computationally efficient. Sounds good. Where can I find a copy of the resources that is discussed here? As always, I'll put it in the description section. You can see it. I'll put this whole IPython notebook and a PDF version of it at the end of this discussion. So don't worry about it, as usual. Okay, next comes my fun part. Okay, so Python's inbuilt data structures. Again, apart from these four, there is also string, but we've already discussed string in the previous live sessions. So my assumption here is that you have basic understanding about these data structures. I'm not going to repeat the basics of them because behind all these live sessions, the assumption is that you already know the basics, right? Now, the big practical question that you often encounter here is which data structure to use where. I'll ask a few interesting questions and would like to hear your thoughts. Okay, again, quick recap. Let's just do a quick recap for those of you who may have forgotten some basics. Again, a list is like this. A list is an ordered thing. This order is important. This order is always maintained in a list. It is indexable, which means this is at index 0, this is at index 1, this is at index 2, and so on and so forth. It is also iterable. We have discussed what is an iterable, right? In the previous live sessions, right? An iterable, again, I've talked about it in the previous live sessions. An iterable data structure is something from which I can pick one item at a time, right? Again, this is very useful if you want to do this for I in list 1, right? So when you want to do this, your lists have to be iterable, otherwise it won't work. So lists in general, the simple concept here is they give you an ordered sequence of objects or numbers or whatever. Again, there is a subtle caveat, which is list can hold objects of different data types, but oftentimes we just use it to hold only one data type, oftentimes. Okay, next, list is very useful, very powerful. So is dictionary. Dictionary, you have this. This is the key, this is the value. This is the key, this is the value. What is the most powerful thing about dictionaries? Given a key, if you give Jack, look, for example, imagine this dictionary is in D. So if I say D Jack, if I just say D Jack, this will return 4098 within order of one time. So using key values, you can search a dictionary in order of one time. As I told you, dictionaries are the most widely used data structures in the industry. If there is, I think 90+% of the times I've seen dictionaries being used. Okay, at least in my own professional experience. Okay, so dictionary is basically key value pairs. This is the key, this is the value, this is the key, this is the value. Dictionary is nothing but a hash table. Again, they are iterable. I told you what iterable is. Earlier, they were never ordered. Again, what does ordered basically mean? Ordered basically means the order in which you input into the dictionary, the same order was not maintained till 3.7. But one of the biggest changes in Python 3.7 is, again, I also realized it very recently when I was using some code. Look at this. What is new in Python 3.7? One of the most important things is, where is our dictionary? Where is our dictionary? Okay, look at this. The insertion order preservation nature. Look at this. This is one of the most important changes in Python 3.7. The insertion order preservation nature of dict objects has been declared to be an official part of the Python language specification. So if you are using a version which is older than 3.7, then the insertion order, right? So the order in which you insert elements in the dictionary is not the same in which you can extract it. That's not guaranteed, right? But since version 3.7, dictionary is also ordered, insertion ordered, right? Next, you have tuple. Tuple, again, remember, lists are represented in square braces, dictionaries in curly braces with the key and value separated using a colon. Tuples are like this. If you want to order anything, if you want to order k same objects, you store, you store that information using tuples. Tuples are immutable, which means you can't change a tuple, just like strings. Again, strings are immutable objects. If you want to create a new tuple from this, that's great. But immutability, again, that's a very important property. Immutable. Those of you who are not sure, let's just Google search. Again, I'm also immutable Python. Okay, so mutable, again, you can find tons of resources in this. Again, tuple is a standard example of immutable. For example, look at this. Tuple 1 is this. If you want to change this tuple 0, this entry to 4, it won't let you do that. Very simple, right? Tuples are immutable, which means once you create this tuple of 4 numbers, if you try to assign tuple 0, which means this value, if you try to assign a value of 4 to it, it will throw an error, which means you can't edit it like that. It's immutable. Immutable means something that doesn't change, right? So that's an important thing. Sets, right? Sets are like this. Sets are just like our mathematical sets. They're unordered. Okay, they're iterable. There are no duplicates. So in a set, if you insert 1, 1, 2, 3, that will be equivalent to the set 1, 2, 3. Again, there is a concept called as multi-sets where multiple repetitions of the same element are allowed. But in the standard set, that's not allowed. They're unordered, which means the order in which you insert and the order in which, so they do not maintain the order. They're iterable. There are no duplicates. Again, there is something called multi-sets where multiple entries, multiple ones are possible. But in the standard set, that's not what it says. Just a quick recap of important properties. There are many other properties which are important, but these are the key ones for our discussion. Again, the most important lesson in whole of using these data structures is the data structure that you want to use is decided based on what operations you want to perform. Right? It depends a lot on what operations you want to perform and how fast you want to perform these operations. For example, let's take this example, right, that we just saw. A dynamic programming example, right? What do I want to do? Given a subproblem that I've stored, that I've already solved, right? Given a subproblem that I've already solved using pattern start and string start. I'll call pattern start and string start. Given pattern start and string start, if I've already solved this problem, it can either be true or false, right? If I've already solved it, I want to be able to search this information very fast. That again, you might say, why the heck did you use a dictionary here? Why not some other data structure? I could have used many other data structures also. But a dictionary has this nice property that given this tuple, given the pattern start and the string start, I can find whether I have solved this problem or not in order of one time. Because my task here is I want to search if I already solved this problem. Whenever you have search problems and you want to search fast, you very often use dictionaries, right? Again, a data structure should always be decided based on what operations you want to perform and how fast you want to perform these operations. Again, I'll show you a bunch of examples, right? Okay, sounds good. So let's go and ask a few questions. So the discussion, the rest of the discussion is which data structure will you use given a situation and why? I want you guys to answer this for me. Okay. Okay, I think this whole thing came into this thing. Okay, suppose, okay, let me just move back. Okay, so the question here is simple. You want to represent a 3D point. You want to represent a 3D point. What data structure will you use? Very simple, right? You want to represent a 3D point, right? Again, in machine learning, in linear algebra, representing n-dimensional points is very common. What inbuilt data structure do you use? Of course, there are also other stuff that you can use, but what will you use? Amongst these four, what do we have? We have list, we have tuple, we have dictionary, and we have set. Amongst these four data structures, that is the core of our discussion, which data structure will you use to represent a 3D point? Any ideas and suggestions? Why? Somebody says array, somebody says tuple, okay? Why tuple, why array? Why tuple, why array? Any three tuple, okay, tuples. Again, I'm just starting with simple stuff, okay? Tuple as it is immutable, okay. Somebody says list, yeah, why not list? Why not array? Why not list? What stops me from doing that? Right? Why shouldn't I store it with a list? Again, one thing that we all know is in a three-dimensional point, when I want to represent a 3D point, again, this is a mathematical notation, not the Python notation. The x coordinate, y coordinate, and z coordinate, this order is important, right? So I can always store it in a tuple. That's good. That's one option. The other option is list. Again, I'm not going to arrays because array is not a basic data structure here. Let's only focus on the four data structure. I can also store it as a list, right? Because list also, it's ordered. List is also ordered. How do I pick between a tuple and a list? Both of them seem to make sense, right? So any suggestions? Oh, actually, why not a dictionary? Any ideas on how we can use a dictionary? Let me go here. Why not a dictionary? Oh, somebody says dictionary. Again, somebody says ND array. I knew people would say this. So you can use an ND array, but remember ND array is in NumPy. It's actually a NumPy class. All I'm saying is amongst the four that we have list, we have dictionary, we have set, and we have tuple. Amongst these four, which can I use and why? So let's remove ND arrays for now, right? Amongst these four. So some of you have said list, some of you have said tuple, some of you have even said dictionary, right? Yeah, some of you have said dictionary. Some are saying tuple is immutable, hence we should use it. Okay, but isn't that application specific? Maybe I want to modify my 3D point. Okay, maybe I want to modify my 3D point. If I represent it as a tuple, I can't modify this 3D point now, right? If I want to send this to some function, let's assume I have a function f that wants to take this 3D point as an input. And if I want to modify this 3D point in this code, then is tuple the right idea? Tuple is immutable, right? So I can't modify it here, right? So yes, somebody says we can use dictionary like this: x-axis, y-axis, and z-axis. Yes. So I think all of us are on the right track. We can use any of these three. We can use a tuple. We can use a dict. We can also use a list. We can't use a set because set is not ordered. I hope that is clear, right? Now let's see, again, whenever you read documentation, This is a very important lesson to be learnt. Okay. Suppose if I want a function f which inputs a 3D point, let's understand how NumPy, again remember the people who designed NumPy are brilliant programmers. There are some very important lessons that we can learn from people who have designed these phenomenal libraries. A lot of software engineering that I personally learned, lot of good practices that I learned by reading others' code, either my colleagues or open source code like this. Look at NumPy. In NumPy, if you look at NumPy ND array documentation, shape is there, right? Shape tells you what is the shape of the NumPy array that you want to create, right? And how is shape represented? Again, I just copied the documentation. How is shape itself represented? Shape itself is represented using a tuple of ints. Remember, the people who designed NumPy are phenomenal software engineers. They would have thought very deeply about this choice. The shape is a tuple because, and why did they choose tuple here? Again, it is these questions that will make you a better programmer in the long run. Whenever you see open source code or code written by others, ask these questions. Why did they choose this data structure here? Again, you cannot learn this in textbooks. What textbooks teach you is theory, right? Which is certainly important. I'm not denying that fact. But if you really want to learn the hands-on aspect to software engineering or writing good code, this is how I learned, to be honest with you. This is how I actually learned object-oriented design, or this is how I learned good programming habits. Okay. The shape, if you think of NumPy ND array, the shape is what you give as the shape of this NumPy array, right? Nobody changes this. Remember, when I create a NumPy array, the shape variable will never get changed within this function. It will never get changed. That's why they said, let's use a tuple because it represents how many coordinates we want. Look at this. It clearly says how many we want on the first dimension, second dimension, third dimension, etc. Right? So this is, again, whenever you read code, ask yourself, why did they use this data structure and not some other data structure? Here they used shape because shape will not be changed anywhere within this function, and it requires an ordered set. It requires order should be maintained. So what is immutable and order, where order doesn't get changed, it is tuple. Okay. So now, one second. Do I have a function here? Okay. A small change here. Okay. Suppose if I want to write a function like this, look at this. I want to write a function like this, a function which takes a 3D point as input, Within this function now, I want to change this 3D point. Again, I can call this, again, this is the function definition, right? I can call this function with the 3D point, right? And I expect this 3D point to be changed. Suppose, let's assume I have a 3D point, 3 coordinates, right? Suppose I have these 3 coordinates and I want to increment this by +1. I want to increment this by +1. I want to increment this by +1. Let's say this function is increment each coordinate. That's a function. That's what the function does. Then what should my data structure be? Any suggestions? List of tuples. List of tuples. How will that work? Somebody says list of tuples. How can we make that work? Somebody says list. Okay, why list? List or dictionary? Okay, why list or dictionary? List or dict? Can you just give a little justification also, please? So that it will become more fun. The discussion becomes much more richer. I know why your argument is list or dictionary. Please. Just write your justification in just a line. The core reasons why list or why dictionary. Okay, everybody is saying list, dictionary, nobody tuple. Thank you, you got it. List or lists. Okay, why lists? Why do I need multiple lists? List or dictionary. All there would be list, tuple or dictionary. Okay, all 3 would be. How come tuple? Okay, tuple is a problematic thing, right? Again, you can do it. Of course, depends on how you are passing the parameters to the function, what you are returning. Again, it also depends on the structure of this function itself. Let's just assume that standard Python, right? Whatever you pass, I hope all of you know how pass by reference and pass by value works in Python, right? Whatever you pass, if it is immutable, it is passed. Again, so suppose if you send an object here, let's assume you send a tuple. Suppose you send a tuple. Tuple is immutable, right? Tuple is immutable. So whatever is the value here is copied here, and you can't modify it inside. But instead of tuple, if you pass a list or a dictionary, remember lists and dictionaries are mutable, which means you can change them. So you can pass a list or dictionary, change this list or dictionary, and return. In the calling function, the changes will be visible, right? I hope all of you know that basic stuff, right? So obviously, you cannot use, again, let's just strike off, right? You can use a list for sure. You can use a dictionary because it is mutable. I want to change the point, right? So I need mutable structures. You can't use set because set order itself is messed up. You can't use a tuple because tuple is immutable. So you're left with these two. That's it. Very simple. Again, you can use elimination also sometimes, a good strategy. Okay, so I've written some small snippet of example. Look at this. Suppose if I pass, okay, so I'm happy I wrote this code. Okay, I didn't recall writing this code, but anyway, good. Suppose if I pass a tuple, right? Look at this. T is 0, 1, 2. I pass this tuple here. I say T0 is T0 plus 1, T1 is T1 plus 1, T2 is T2 plus 1, and return. Right? It gives you a type error. What does it say? Okay, I don't think I can read it here, but we can go down here. Okay, so what does it say? It says tuple object does not support item assignment. You can't assign something to a tuple. So what is this? This is an assignment statement, right? I'm assigning something to the value of T0. So tuples do not allow that, right? So that's the error. Very simple. So that's the code snippet. Just wanted to show you a code snippet to convince you that yes, they're actually tuples are immutable. Okay, again, instead of that, if you did it with a list, right? So here, look at this. Here my T is a list, right? My T is a list. I'm passing my T. Okay, I'm passing my T here, right? I'm modifying my T. I'm returning. I'm not returning T. I'm just returning. So from the calling function, so this T now gets modified. If I print T now, look at this. If I print, so before I call FT, first let's see what I've done here. First I have T012, I printed it. Okay, so this print statement printed this. I also printed T0. Okay, cool, got this. Then I called FT. When I call FT, what happens? The reference to this object T, the reference is passed here, right? Are actually a copy of the reference. Again, Python uses a slightly confusing terminology, but logically, if you think about it, whatever changes I do here are also visible here. Nutshell, that's what it is, because T is a mutable object, right? So let's assume I increment all the 3 coordinates. Now if I print T, look at this. The values went from 0, 1, 2 to 1, 2, 3, right? Lists are mutable and ordered. That's why when you pass it to a function, whatever changes you make here are also visible from the calling region. Very simple example. Okay, again, if you are not comfortable about immutability, mutability, parameter passing, there is a very nice post that I've seen on Wikipedia. On Stack Overflow. Stack Overflow is almost like Wikipedia nowadays. Okay, so it says list is mutable. He writes a code to show you that list is mutable, right? String is immutable. So he shows you some small snippet of code. Right, so I like this explanation. So if you have time, please go through this explanation. Again, arguments are passed by assignment. Again, the term is assignment. Again, people who learned C programming first, we know pass by reference, we know pass by value, right? This is called pass by assignment. Okay, that slightly confusing terminology, but it is very similar to pass by reference. Those who know C programming, right? If you don't know, that's okay. Those of you who are confused how arguments are passed, please go through this. It's a very nice post on Stack Overflow. I'll share it with all of you. Very simple code, very easy to understand. Very nice explanation actually. Okay, I closed it. Okay, so let me just start give me a second. I stopped the slides. Okay, I stopped the slideshow by mistake by closing that window. Okay, let me just go ahead. Key properties, again, I'm starting with some simple examples. We'll go to slightly more complicated ones slowly. And again, throughout this series, we'll see a lot of examples. Okay, this is a good question. Imagine if you were to design NumPy from scratch. Imagine you are the designer of NumPy Again, I really like these types of questions. These are my personal favorites because eventually everybody grows up and becomes a good software engineer or machine learning engineer, right? Imagine at some point you have to design NumPy from scratch. Which inbuilt data structure would you use to design ND array and why? I hope the question is clear. If you were to design NumPy from scratch, you cannot use NumPy. You're designing NumPy from scratch. NumPy does not exist, let's assume, and you're designing NumPy from scratch. And you have to use one of the inbuilt data structures for ND array. What data structure will you use? Any suggestions? And why? Obviously, why? Oh, so there are other, yeah, somebody's talking about multi-core environment. Yes, there are other, again, I'm not even going into more complex like multi-threading, multi-processing, distributed computing. I'm not even going there, right? So that's a big beast onto itself. We'll probably do one of those in this session also. I'll probably do one session on multi-core programming, but little later. Multi-core programming and or multi-threading. We'll discuss that later. Okay, somebody says list. Okay, list. Dictionary would work because of array. Okay, yeah, you can make dictionary also work. List of list. Okay, that's good. You'll use lists of lists. Exactly. What are two-dimensional lists? Good. We all are together. See, if you want, what is your ND array if you think about it? Let's think of 2D ND array. Again, you can do any dimensional ND array, right? So if you have list of lists, right? If you have list of lists can be thought of as a 2D matrix, right? So list of lists is what you can use to design simple ND array. Now let's go to a slightly more interesting question. Those of you who are experienced software engineers should take a shot at it. Okay, so good. So what will you use? List of lists. Very simple question. Now comes the fun problem. How do you think data is actually internally stored in NumPy arrays? Okay, so in the previous question, there is a subtle difference, right? In the previous question, my question was, if you were to design NumPy from scratch, what inbuilt data structure will you use? Cool. Next question here is, how does NumPy actually store NumPy ND arrays? By NumPy arrays, I mean ND arrays. How do you think it actually stores them? Have you ever seen the documentation of NumPy? Right? So again, it doesn't store it as list of lists. Let me make that clear. It does it using something much more ingenious. Again, if you are a fresher or if you are a youngster, you may not know this, but experienced software engineers should take a shot at it. How do you think data is internally stored in NumPy arrays? Okay, class. Yes, it's a class, obviously. NumPy array is a class, yes. NumPy ND array, as I discussed in one of the previous live sessions also, is a class. But how is the actual data? At the end of the day, NumPy ND array has to store a bunch of numbers. It has to store a bunch of numbers. What data structure does it use to store these bunch of numbers? Dictionary, hash table? No. Very complex. As NumPy is implemented, static arrays in C or Fortran list is closest. Yes, interesting. Okay, that's a good idea. So somebody says, okay, this is a good idea. Okay, let's hear others also. Hash table, dictionary in the form of a dictionary. Okay, linked lists. Okay, let's hear it out. Key value, dictionary, key value pairs. Okay, dictionary with index as list and lists as values. Okay. Again, there is again, I know where all of you are going from, but let me tell you a problem with dictionary, right? Let me tell you what could go wrong. Suppose if I store an ND array as a dictionary, suppose I store it using a dictionary, and the dictionary will work like this. The key will contain the coordinates, right? Basically the index. Suppose let's assume it's a 2D. Okay, let's just say it's a 2D instead of 3D. Let's assume I have a 2D ND array, right? Any value that I want to access, I can access using the row number and the column number. So this is your row, this is your column number. That's my key. My value stores the actual number, right? This is what I think all of you are hinting at. There is one problem with this. Imagine, okay, again, I'm happy you're thinking. What this solves is, it will make accessing very fast, right? It will make accessing very fast because dictionaries are super fast accessible. Cool, I'm very happy you thought about it. But there is one problem with this. Okay, so the problem here is this. Okay, let me use a different color. Okay, suppose if I have two ND arrays, A1 and A2, if I want to add them, and stored the result in B. This is a two-dimensional array. This is a two-dimensional array. Or in other words, they're matrices. This is a matrix. This is a matrix. Right? Now, this is one operation. And the other operation, more interestingly, if I want to resize, actually that's a more tricky one. Forget about this. If I want to resize, okay, suppose if I have matrix A, which is 3 cross 5, we have shown in our first live session that I can resize this into A 1 cross 15. Resizing. Resizing is something that is done a lot on NumPy arrays. Right? Resizing. I'm just changing the shape from 3 cross 5 to 1 cross 15. Can this be done fast? Can this be done fast if I use a dictionary? Because the data structure should depend on what operations you want to be able to do fast. You can do accessing very fast using a dictionary. But can you do resizing, which is a very, very common operation on NumPy arrays, NumPy ND arrays? Can you do this fast? Can we do this fast? Let's hear you guys. Dictionaries with index as list and lists. Okay, that's complex. List with homogeneous functionality, contiguous allocation, byte-like object, pointers, sequential, balanced BST. Okay, why did we get binary search trees here? Balanced BST. Why are we using a BST here? I can't imagine this. Anyway, that's okay. Anyway, everything has to be stored in binary, guys. That we know, right? Stack. Okay, how come a stack? Dictionary makes reshape logic complex. Yes, I'm happy you got it. Prasad Raju. Yes. Slicing, I think from my deep mind. Slicing. What is slicing? I didn't understand the context. I don't think NumPy is written in Python. I think it would have been written in a low-level language. Yes, you're right. NumPy, if you look at the documentation of NumPy, again, if you have time, you should actually, again, there are like list of tuples. None of that works, by the way. Okay, so I've copied a small, again, there's a very nice IPython notebook called as Understanding the Internals of, let me open this. It's a very nice cookbook. Okay, this is a book called, this is about IPython, all of that. But here, this post is all about how NumPy works internally. Okay, so again, broadcasting, there are tons of techniques here. Why is, again, the question here is, why is NumPy arrays efficient? I just Google search for it and I found this very nice resource. I've pasted what is there here. A NumPy array is basically metadata, okay, blah, 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 and the actual data. This is the fun part. As somebody rightly pointed out, all the core underlying functionality of NumPy is actually implemented in C++. Okay, because C++ is where you get speed for any numerical computation. For any numerical computation, the underlying thing has to be C++ because that's where you get speed from. And C++ gives you a lot of low-level control on your RAM or main memory. Right? Those of you, again, if you know TensorFlow, a very, very popular library for deep learning, the core of TensorFlow is actually written in C++. There is a Python interface to it. You can call most of the functionality from Python, but all the low-level stuff is actually operating on C++. Right? So, in a nutshell, what it does is, it gets a contiguous block of memory. Okay, again, those of you who know C, you can get a contiguous block of memory using malloc. Again, if you don't know this, don't worry. I'm just, for those of you who know C, again, I think all of you must have learned C in your BTech first year, right? Most of you at least. Even if you're an MCA student, I'm sure you would have learned C, right? So malloc, you can allocate a chunk of memory or a block of memory, and that's what is used, right? Because the code, everything, reslicing everything, and NumPy data, like for example, all the other information is actually stored in a class, and all that is stored as metadata. For example, the number of rows, the number of columns. Suppose imagine if I have a chunk of memory, this is in my RAM, let's say. Within my RAM, I have a bunch of space which can store 15 numbers. Okay, some bunch of memory where I'm storing some 15 numbers, right? If I want to resize, I'll just change the number of rows and columns. The way I access this memory location will change. The data in the memory location itself need not change. If I use a dictionary, like what we saw earlier, if you use a dictionary, I'll have to recreate the whole dictionary. So this resize operation will be order of n. If I have n elements in my ND array. Why is it order of n? because you have to take all the elements here from one dictionary and create a new dictionary. Let's call it from D1, you have to create a new dictionary called D2, restore everything. If you're storing it as a chunk of memory, it's literally like raw memory that you can access in C, C++, nothing changes here. The memory doesn't change. Corresponding to ND array, you'll just say for this ND array, how many rows are there, how many columns are there. Again, these are like attributes that you have in the class ND array. Again, tomorrow's session is actually basics of object-oriented programming in Python, where we learn this in a lot more detail. So earlier I had 3,5. I'll just change it to 115. The memory doesn't change. Only the representation of the memory changes. So I can do it in order of one time, right? So very interestingly, again, if you want to go into the depths of NumPy, you can spend years learning NumPy, to be honest with you. Again, you can get access to the C code also, but it will take you years. But I just wanted to throw this question at you to understand the limitations of inbuilt data structures also. You cannot use them everywhere. Okay. Next, if you want to write a program to get various combinations, this was an assignment problem, if you recall, when we learned permutations, I think in our session 2, live session 2 or 3, I don't remember, I think 3 probably, 2 or 3, one of these 2 live sessions, right? I said you want to print various combinations. What is combinations? Again, from permutations and combinations, imagine if I have 1, 2, 3, 4, 5, right? And if I want, let's say, combinations of 2, what are combinations? You get 1, 2, you get 1, 3, you get 1, 4, 1, 5, 2, 3, blah, 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 blah. All these are combinations. So if you want various combinations from a given set of numbers, given a set of numbers, right? Let's assume no number is repeating. That's why I'm calling it a set. Let's assume you have a set of numbers and you want to create all the 2 combinations. How will you store the results, right? How will you store the results now? Suppose you're writing a function, right? You're writing a function called find combinations. Okay, so this is your function. Okay, all the initial set of numbers is given as a set, and whether you want 2 combinations or 3 combinations is given as an integer. How do you want to give the result back? Okay, what data structure will you use? Any suggestions? Where is order important? Python arrays, as there is C concept there. Yeah. At the end of the day, NumPy is all implemented in C, C++. Okay, somebody says list of tuples. Why is it a list of tuples? Any justification, guys? So somebody says, I'll return a list of tuples, 1, 2, 1, 3, 1, 4, and so on and so forth. This is what a list of tuples is, right? Sets of tuples. What is sets of tuples? You have a set. You have a set of tuples. 1, 2, 1, 3, 1, 4, so on and so forth. This is what you will return. Okay. Set of tuples. Okay. So this is set of tuples. SOT. This is a list of tuples. Okay. Is that the best way? Is there something better than this? Somebody says dictionary. Again, please don't throw dictionary at every problem. Okay, there are some problems intentionally that I've picked where dictionaries. Tuple of tuples. Okay, so tuple of tuples. What does tuple of tuples look like? Oh, sorry, tuple of tuples. 1, 2, 1, 3, 1, 4, blah, 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 blah. Tuple of tuples. Okay. Set. What set? You have set of what? See, people are suggesting list of tuples, set of tuples, tuple of tuples, because you get multiple answers here, right? So if you notice, where were they? Okay, so in the previous one, tuple of sets, tuples of set. Okay, tuples of set. What does tuples of set look like? Tuples of sets. Okay, 1, 2, 1, 3. 1, 4, blah, 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 blah. Okay. Why is it so? Oh, I would like to hear your set as it holds uniqueness. Okay. Sets to some extent make sense, but can you please give one-line justification? Please? Sets of tuples might be right. No, sets of tuples. That's what somebody is suggesting. I think we have written a lot of them. Okay, again, depends on the application, but if you think about it, look at each of the results. Is the order important? First, let's start with basics. If you're returning this, is the order important in combinations? What is one of the most important properties of combinations? That the order is not important, right? So suppose if you have, okay, let me show you this slide. Okay, so this order is not important, right? Whether it's 1, 2 or 2, 1, it's the same thing in combinations. Permutations, the order is important. In combinations, the order is not important. So each of these results that you want to store, do you want to store it as a tuple or a list? Because a tuple or a list, order is important, right? Do you want to store it in a tuple, or how do you want to store it? So think about it. It's a very simple one if you think about it. Okay. Sets of tuples. Again, there are no right answers here, but for any answer you give, you have to justify. That's important. Combination does not require order. Yes. So this does not require order. So each of these results, they're order independent. So why are we using it? Why are we using tuples here? Why are we using tuples, or why are we using lists? Right? Why are we using tuples? We should be using sets, because in a set is order independent, right? So to store each of these combinations, using a set makes sense. Obviously, good. Okay. So one idea here is, let's store each of the results in a set. Again, this is not the only right solution. It all depends on more complex cases or operations that you want to run, right? So if I store each of these like this, because the order is not important. Next, these results, in what data structure do I store? If I store it in a list, remember, if I store it in a list, order again becomes important, right? If I store it in a tuple, the order again becomes important. Now remember that combinations, if you encounter 1, 2 once, you will not encounter 1, 2 again, right? Because each entry will be unique, right? You want to print each combination only once, right? So one way, I'm not saying this is the only right way, but one way to think about it is a set of sets. A set of sets. Mathematically, it makes a lot of logical sense. Because why is it set of sets? First, we have understood why this should be a set. Because the order, it's independent of the order. Why this has to be a set? Because you will not encounter 1, 2 again anytime. Each entry here or each object here is unique, right? So set of sets is one option, right? For our case, again, there are many right solutions. I'm just forcing you to think of other options. That's all. Okay. So now if you look at it, okay, now let's look at what professionals have done. Okay. So let's go to Python document. This is Python 2 documentation, but that's okay. Because if you recall, in Python, when we saw the example, there is iter tools, if you recall, right? So there is iter tools which can give you a list of combinations. How is the input given here? The input is any iterable. Remember, again, this is implemented by professionals. In iter tools, the input is any iterable. It could be, I can give it as a set. I can give it as a, I can give it as a list. Any iterable object is okay. It could be any iterable object, doesn't matter. And why iterables? Because they want to iterate over each of this. The way they've written the code internally for combinations requires this to be iterable. It could be anything. So the iter tools combinations in the input, right? Again, mathematically it doesn't make sense, but in the implementation, you can have elements repeating. For example, you can give this input. You can give this input and say, I want combinations of 2. Okay, then it will treat these as unique values. Okay, that depends on the implementation. Now, again, what does it output? Okay, returns R-length subsequences of elements from the input iterable. Again, the best way to learn is thinking through yourself, also reading others' documentation and trying it out. Okay, iter tools, let's actually try it, right? Why not try it? Just give me a minute. I'll just open something here, blah, blah, blah. Okay, so let me just open this, combinations, okay. Insert cell below. Okay, let's write it. Import iter tools, and Again, I come from C world, so I have a habit of putting semicolons at the end. So the syntax is simple, right? Just print it. Okay, so let's assume iter tools. Okay, let's just say result equals to iter tools dot combinations. I can pass combinations. Iter tools dot com. Again, you can always type tab just to get it. Suppose if I pass 1, 2, 3, 4, 5, right? And if I want combinations too. Okay, this is my result. Okay, so print, what is the type of the result? What is the type of the result? Okay, let's just run this. Okay, it has a different thing called iter tools dot combinations. So the data type it is resulting is another class called combinations. It is not resulting a set of sets. Now you can go and see how is iter tools dot combinations. How is it stored? Okay, iter tools dot combinations. Where is combinations? Again, it depends on how it is storing it internally, right? Iter tools dot combinations. Iter tools dot combinations. No. Iter tools. Okay. Again, we can spend some time on this, but just go through this process. Now we know what is the data type that it is returning. It is returning iter tools dot combinations, an object of type iter tools dot combinations. Now we can go into iter tools source code or iter tools documentation and say, how is this data type constructed? Is it a set of sets, or is it a set of tuples, or they may not have used any of the inbuilt data structures for optimization, right? So again, this is a good exercise in general to go through professionally implemented snippets of code to understand more. But in the interest of time, I'm just moving ahead, but just try to see how iter tools dot combination stores this, right? Okay, we have seen a bunch of questions. Now I want to take you through a real world problem. Okay. Suppose, again, this is a very, very popular interview question. How do you build a tiny URL service? I hope all of you understand what is tiny URL, right? So tiny URL service is this. For example, I can say AppliedAICourse.com, right? Make tiny URL. If you give any long URL, it will take a long URL and it will shorten it to this. So now if I go and do this, look at this. If I go and do this, if I click enter, it will take me to AppliedAICourse, right? If you have long URLs, these are called as URL shorteners or tiny URL, right? So how do you build a service like tiny URL? Think about it. It's a very, very popular interview question. I mean, I have personally asked variations of this question in my own interviews earlier. Again, this requires you to know only basic knowledge of Python and data structures. Basic data structures, nothing complex. It's a very popular interview question. Any ideas how we solve this? Okay, we have about 40 minutes, right? I hope we can complete it. Yeah, we'll complete it, don't worry. Sorry, linked list. Okay, all that is okay. Please print. Okay. It's returning tuples. Okay. Oh, somebody is concerned about this question. Again, the print itself could look whichever way you want. Suppose but the data type is the important thing, right? If I print it as res, if I print result here, okay, print res, what happened? Okay, print result dot, I think it will have some print. Again, I'll have to look up the documentation. I don't remember it at the top of my head. But what is important is the data type. That's why the reason I print type res is I wanted to understand what is the data type that it is returning. It is returning a custom data type that it has defined, not a standard set of sets or tuple of stuff, right? So back to our question. Imagine we want to build a tiny URL service. Okay, how do you build it? Okay, what data structures will you use? How do you build it? Any suggestions? Somebody says dictionary. Okay, why dictionary? Dictionary, tiny URL, full URL. Okay. Let's ask ourselves, what are the two operations that we want to perform? That's important, right? There are two key operations. The first operation is create a tiny URL. So given a long URL, so there are two operations that again, whenever somebody says design something, you should first ask yourself, what are the two operations or three operations that are critical here, right? The first thing here, or somebody says print result, zipping URL. Yeah, please try it. I mean, there are many. We can always go into the documentation and read it also. But anyway, somebody suggested it. I mean, I'm stuck with this. So somebody says, let's type print res. Let's see what happens here. Oh, it's actually storing it as a list of, but what is the star doing here? Okay, okay. But again, the data type is the more important thing as I see it, right? So, because when you print it, probably this is how it is stored. Certainly one way. Again, I'm not saying one way is wrong or right. You just have to justify your answer. There is no right or wrong. I mentioned this earlier also, right? It all depends on what operations you want to perform beyond this. Okay, so, okay, back to our question. What operations do we want to perform here? First operation that we want to perform here is, given a long URL, we want to obtain a short URL. That's the first task. The second task here is, given a short URL, we want to perform the long URL fast. Very importantly, we want to, because when somebody types, look at how this works, right? Suppose if I go to my browser and if I type this short URL, this is going to take me to the web server where tiny URL is hosted. The tiny URL has to, given this short URL, it has to give me the long URL and it has to redirect me to the long URL, right? So there are two operations that are important. So first operation is this operation. I enter a long URL, it should give me a short URL. Second operation is, when I enter a short URL, it should quickly convert that into long URL and take me to that website. Basically, this is what I want. Okay, so where are we? Okay, so these are the two operations. Where were we? Okay, okay, here. Okay, we are here, right? So store long URL as key, short URL. Okay, one second. Okay, somebody is saying let's use dictionaries. Okay, cool. That seems like a good idea. Somebody says tuple also. We'll see tuples also. So in a dictionary, you should always ask yourself, what is the key, what is the value? So what somebody is suggesting here is that they will create long URL as the key and short URL as the value. That's the suggestion, right? But will this work? Can anybody tell me? Oh, someone else is saying the opposite. Okay, is this approach correct? A is correct, or is B correct? Where you have key as short URL and value as long URL. These are the two options that I see here. Storing this information. Somebody says red black tree. Why the heck should I use a red black tree, dude? Tell me. Red black tree is still order of login. I want order of one search. Why should I use a red black tree? I'm being honest with you. I've seen people saying I'll use a binary search tree, I'll use all this. Why the heck? I have a dictionary which is order of one, amortized order of one. I'll just go ahead and use it. Why should I use some fancy? I've done this in some interviews. Somebody suggested let's use a red black tree or an AVL tree. I asked him, explain me and write the code for deletion from red black tree. I actually asked this in a question. So some people say, okay, I will use a red black. I've done this in some interviews. Again, I don't want to contradict them. I said, okay, you said red black tree. Tell me, how do you delete a node from a red black tree and write the code for it? Done. The interview is done with that, right? Because it's extremely, you have to be extremely careful to write that code. Okay, somebody says option B, somebody says option A. Okay, so there is some confusion. Let me clarify that. Option B is a more sensible thing, right? Because given a short URL, we want to convert to a long URL. Fast, very fast. Because I want to visit my websites fast. So my search is based on short URL. Given a short URL, I should get long URL fast. Right? That's important. This has to happen very fast. So this representation makes a lot of logical sense. But now the other question is, given a long URL, how do you generate a short URL first? Right? There are two parts to it, right? Given a short URL, you can get a long URL by storing short URL as key. So key is short URL. I'll just write SURL. Value is long URL. You're done. This is a dictionary and you're done. Problem solved. This is order of one search. Right? Long URL to short URL. How do you design this? Both ways. Oh, somebody says both ways. Okay. How long is the short URL? How long is the short URL stored for? Good question. Let's assume you want to store it for a few months. That's a good question. That's a very good follow-up question. Let's assume given suppose I go to tiny URL. Let's assume tiny URL wants to store this for, let's say, at least 90 days. At least. Let's assume it wants to store for 90 days. That's a good follow-up question. But again, we will not go into software design, software optimization, distributed hash tables, all of that stuff, right? How do we go from long URL to short URL? That's my question. So given a short URL, we can find the long URL if we just store it in dictionary very quickly. How do we go from long URL to short URL? Hashing, hash function of what? Base 16 encode hashing. Yes, these are certainly some approaches. Anything simple? Much more simpler than this. Regular expressions for what? How do you use regular expressions here? I can't even imagine. Or am I missing something? I know how to do it using base 64. I know how to use it using some hashing. Yes, that's it. Somebody gave a very good suggestion. Just create a random length string. Problem solved. So when somebody gives you a long URL, the idea is very ingenious. Right? When somebody gives you, Arun, very good. I think you've also given good solutions in the previous live sessions. So given a long URL, just create a random string. That's one of the simplest ways. Again, I'm not saying that's the only way of doing it, but there are many other ways of doing it. Base 64 encoding, yes, I agree. There are some hashing based solutions. The simplest is let's just generate some random string. Problem solved. Okay, now let's go through the code for it. Let's actually do it. Right? So let's actually do it step by step. Okay, cool. Dictionary or hash table, key equals to short URL, value equals to long URL. And how do I generate the key? It's basically a random variable length alphabetic suffix. Right? I'm using basically a random alphabetic. I'm using random alphabets here, but instead of making it fixed length, I'll make it variable length. Again, you might say, why are you using variable length? Because if I fix the length to only 6 characters, right? The number of characters, the number of strings that I have here is fixed, right? Imagine if I'm using only lowercase ASCII values, right? Or A to Z basically. Let's assume I'm using A to Z. I have 26 power 6. This is all I have, right? 26 power 6, right? 26 power 6, yes. That's all I have. What is 26 power 6? Let's actually compute that. 26 power 6. What is, oh, come on. 26 power 6. Come on, Google. Okay, so this is only 30 million web pages. Too small for the internet. Look at this. This is what? This is, 300 million, I'm sorry. 300 million URLs. That's too small. If you go to tiny URL web page, they say, look at this. They say making over 1 billion URLs usable. Right? They're serving literally billions of redirects per month with billions of URLs. Right? So the idea here is instead of just using fixed length, let's make it variable length. This length, let's assume I'll randomly generate, but the length can be anywhere from, let's say, 6 to 10. Let's just say variable length. But of course, the minimum length will be 6, maximum length will be 10. Now I can generate billions of alphabetic suffixes or random numbers, right? So let's go to the code of it. Very simple, nothing fancy. Here is my dictionary where I'll store everything. Look at this. I have a dictionary where I'll store everything. I'm just importing random and string because those are the operations that I'll do. Here is my function which is get short URL, right? Here I'm generating a random integer between 6 to 10. Again, randint is there in random, right? Randint basically generates a random number between 6 to 10 and that random number is L. If I print it, I'll get it, right? Next, I want to generate a random characters into a string of length L. So what do I do? Again, this is a very interesting code. There are many ways of writing it. I've written it very succinctly to teach you more approaches. So in string.ascii lowercase, look at this, in string.ascii lowercase, I can get all the characters that are lowercase characters only. First I get that. Now look at this. This line is very interesting. Now what am I doing? I'm saying in all these characters, random.choice. What does random.choice do? If you don't know, just Google search, read the documentation. Given these characters, it will pick one of them randomly, right? It will pick one of them. Very simple. Okay. Now I'm also joining. Look at this. I have a string.join. I hope all of you know what join does, right? It combines these characters. It simply combines these characters. Now before we go in here, look at this. This part is important. So this code will execute first because it is in the parenthesis, then comes the join. So random.choice chars. So what this does is it generates a random character from all the characters that I have here. This basically is all the characters which are ASCII lowercase. From them, I'm picking one of them. but for I in range L. So I'm repeating this operation. L times. L itself was randomly generated, remember. Again, this is a very nice one-liner to generate the short URL. Again, you can write this using a simple for loop. If you're not comfortable in this notation, you can write a for loop. But I wanted you to get comfortable because you'll see syntax like this in others' code, right? So my suggestion here is, so what happens? I'm first picking a random character, but I'm repeating it L times. So what do I get? I get L characters, right? Now I'm joining, look at this, empty string dot join all these L characters. So what do I get? I basically get now a string of L characters. That's what my short URL is. I'll just print it again. As usual, as you know, I always print what is happening. Now comes the most important part. If short URL is already present in my dictionary, what does this do? This says, is there a key in my dictionary already wherein the short URL is all, is there an existing key with this short URL right? Is there already a key which is equal to the short URL? That's what this does. If it already exists, right? The randomly generated string, let's assume my L equals to 6. I generated a random string. It happens very rarely, but what if the same string is generated again, right? It was generated once, I've stored it in my dictionary. I've generated again because I'm randomly generating a string, right? Suppose the same string got generated, very low probability. Let's assume it happened. Then what do I do? Then I will simply call this function again recursively. I'm going to simply call this function again because the next time it generates random string, the probability that next time also such a short URL is present is very low. First of all, finding it the very first time itself, the probability is low. But again, this is a boundary case that you should always handle. Lot of people miss this boundary case, right? This is an important boundary case that you should handle. If the short URL that I randomly generated is already there in the dictionary, just regenerate it. Just call this function again. Next time it will generate a completely new random number generator. It will completely generate a different short URL. Next time also, if it's doing the same thing, then go back again. This is a very important boundary case that people miss. If it is not there, just add it. This is how you add something to a dictionary, right? Done, right? And you just print it and you return it. In my return, let's assume my company name is not tiny URL. Let's assume it's short URL. I'll just take short URL and I'll add it. Done. Problem solved. Right? So let's see how this works. Okay. Suppose if I give get short URL AppliedAICourse.com. Again, I always print what is there. So this is there. This is what is there in my dictionary. It entered. Again, the random number generated L is 8. It generated a string of length 8. It entered this into my dictionary and it returned this because I have the print statements. I want to understand how my code always works. Next, suppose again, same long URL I'm giving again. Look at this, same long URL I'm giving again, right? So most URL, so tiny URL, right? So we just generated something right now. Suppose if I try to say generate again, it gives me a completely new, see, look at this. It gave me this URL. Look at this, the current URL is WJZH, right? Let's just remember that. If I generate again, oh, it gives me the same, okay. Make tiny URL, okay. It's actually searching if that already exists and it's giving me, okay. So that's the next level of improvisation. But let's assume we don't care. Every time I'll just generate a random string, 2 random strings can point to the same URL. Let's assume that's what we are doing. Of course, we can optimize this code further and say if a long URL already exists in my in my dictionary, I don't want to again create it. In such a case, you might have to store one more dictionary. You might have to store dictionary 2 where the key is the long URL and the value is the short URL, right? So this is useful. Again, what do you do here? Whenever you get a long URL, first you search in this dictionary. If that long URL already has a short URL that is already assigned. If it is not assigned, then you create this random string, right? So that's the next level of optimization, right? So very simple. Again, an interviewer can say, okay, this is cool. How do you optimize it further? Then you can say, I'll have 2 dictionaries. Problem solved. Okay. Now, how do we get long URL? Very simple. Very simple. So I'll just say, extract, so k equals to short URL, right? So when somebody gives me a short URL, the short URL will have shorturl.com / this, right? So from this, I should extract, I should just ignore all of this. I should only take this part. So I'm taking from the 25th character onwards, right? This is my short URL. I'll just print it and I'll return DK. Problem solved. Is it? Does this work? Is there a problem in this code? Right? I hope the code is, again, here what is the function? Get long URL. Given a short URL, we should return the long URL. Right? What am I doing? Given this input, this is my short URL, right? This is what I put on my web browser. I'm removing this whole thing. I'm just taking this, this random string and I'm searching for this random string. Just return DK. Is there a problem in this code? Can anybody suggest me a bug in this? Is there a problem in here? Is there a problem in this code that I just showed you? This is my get long URL code, right? I showed you get short URL code, right? Just a while ago. This is my get long URL. You're basically, what are you doing? You're just trimming away all this prefix. You're only taking the random string and you're searching for that in your dictionary and returning it. Is there a problem here? Is there any problem? If I use, oh, the short URL doesn't exist. Good. Yes, that's a problem, right? So the short URL doesn't exist. In such a case, what happens? If the short URL, if k, suppose if I give some a, b, c, d, e, f, let's actually see that, right? I have written some, okay. So get long URL, I got this, also, I'm just testing my code, okay? So this snippet of code, I'm just testing, okay? So if I just modify it like this, get long URL, mx blah, 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 it gives me AppliedAICourse. Cool, very good. Now, if I give something a, b, c, d, e, f, if I give a, b, c, d, e, f, what happens? It gives me an error. It gives me something called as a key error. Now, what is a key error? This key doesn't exist in the dictionary. And where does this whole thing occur? Return DK, right? A, B, C, D, E, F as a key doesn't exist. That's why it's giving me an error. How do we fix it? Just handle that boundary case. Very simple. Just handle that boundary case. Again, this is a good exercise in boundary case testing, right? You just say, okay, you first truncate, you just remove this whole thing, just get the random string. You first say, if the k is present here, return DK, else return none. Problem solved. That's it, right? So always handle your errors carefully. Now, if I give a, b, c, d, f, it returns none. Okay, you have to handle boundary cases. If I return a valid random string, it returns as expected. Okay. Okay. So next. Okay. So let me just set you up for the next live session also. So in this example that we have seen, we had a dictionary D, right? We had a dictionary D, right? We had a dictionary D where we are storing some data. And we had two functions, get short URL and get long URL. Get long URL, right? So these are the two functions that we had. Now, if you realize these two functions are operating on this data, that's how we have written our code, right? Now, if you think logically, all these things, if you can somehow put them into a single logical structure, imagine if you can put this whole thing, again, I have some data, I have some functions which modify or which use this data, right? This is like a variable, right? This is basically a variable of type dictionary, right? So I have some data or some variables and I have some functions which operate on this data. Now, if I can somehow group this whole thing logically, group them into one system logically, right? Or a single block logically, then you get what is called as a class. Again, the next live session that we will have is called the basics of object-oriented programming in Python. Here, I assume that you already know what is a class, again, I'll recap some of these concepts. I will recap some basic concepts of object-oriented programming in Python, but I will tell you in the context of real-world problems. So tomorrow what we'll do is, we'll take this URL shortener, okay? We'll take our short URL service. So we'll create a class called short URL, right? Because that's a problem we are solving, right? Again, URL shortening is a interesting real world problem. It's not some cooked up toy problem for interviews. It's a real problem. Again, I personally prefer asking more real world problems like this, my personal preference. Not everybody has that, but my choice. So we will understand object-oriented programming you by first building a class for this, understanding in this real world context. That's why I've postponed object-oriented programming. Again, I don't want to promise tomorrow, but the next live session, whichever we conduct online, publicly to everyone on YouTube, we will cover basics of object-oriented programming. Again, I will not be covering all the boundary cases of object-oriented programming in Python. I will cover what is required in the context of machine learning, because 2 hours is not sufficient to dive deep into object-oriented programming in Python. But I'll give you everything that is needed for you to be a good programmer using basic concepts of object-oriented programming. I'll not go into complex object-oriented design, all of that stuff. But I'll give you an intuition on, again, what we'll do is, we will solve this problem, the short URL, whatever we have just discussed right now, we'll put everything into a class. I'll also show some examples from other major libraries in Python on how object-oriented programming is used by these libraries, because that's the best way for you to appreciate instead of taking up toy examples, right? Sounds good. So that's the next session, but we are not yet done. Okay. One more, again, I'm just giving you some simple questions here. We have 20 minutes, right? Let's solve a few simple questions. Suppose I have 3 lists here. Okay, list 1, list 2, list 3. Okay, I want to find the common element in these 3 lists. Very simple question. Okay, I want to find all the common elements in these 3 lists. Now, if you notice, 1 is there here, 1 is there here, but 1 is not here. 3 is here, 3 is here, 3 is not here. Only 4 is the common element, right? Only 4 is the common element in these 3 lists. Now, what data structure will you use to solve this problem, and how do you do it? Very simple question. Nothing fancy. So somebody is asking, can we do graph theory for machine learning also? I think hopefully in this series, actually in our course videos, we already have covered some of it when we solved the problem of social network analysis, because we have designed some features based on graph theory algorithms. If time permits, we'll try to do something on graph theory in the future sessions. Convert to sets and take intersection. That's it. Simple. It's 2 seconds. I mean, it's literally 1 line code. You can write it in 1 line, but anyway, very few. Suppose imagine if I have these 3 lists. I convert the lists into sets using this. Again, tomorrow I'll also tell you about constructors, all of those concepts also, when I teach you about object-oriented programming, right? But please, if you can, please revise the basics of object-oriented programming. There are tons of resources online. You can pick any one of them. But I will not teach from a toy example perspective. Oops, Python. Just Google search for it. You'll get tons of resources. I mean, go to any of these pages. I've heard real Python is actually good. Object-oriented programming in Python 3. Again, oh yeah, I've seen some of these examples. So just go through something like this. Okay. Again, I think they're using a simple toy example. Yeah, they're doing dog, cat type of example. We'll try to pick up a real problem, or we'll try to pick up real examples instead of toy examples, so that you can connect why this is working. Again, just refresh the basics of object-oriented programming so that we can spend more time understanding why it is used, how it is used, etc. Right? So I created 3 sets. All I'm doing here is set1.intersection s2. This will result in another set. So intersection s3. All that result I'm converting into a list and I'm sending it. That's it. Problem solved. Literally, like, this is the key line. Set1 intersection s2 intersection s3, convert into list and print it. Why am I converting into list? Because I want the output to be in list. Because I wanted the output to be in list. That's why I'm converting it to list, right? Very simple example. Okay, so do I have something? Nothing here. Okay, so this is a good exercise problem, right? Since we have seen some examples, I'll explain you how to solve this problem. This is an interesting real world problem. Suppose you're given a bunch of, let me explain the problem. I will not write code for this. I want you two guys to do it, right? So take a bunch of documents, any text documents. If you want, just download a bunch of pages from Wikipedia. That's okay. So imagine if I'm given a bunch of documents. Let's assume I have document 1, document 2, document 3, document 4, so on and so forth. Let's say some 10,000 documents. Okay. I want you to build a very simple search engine. Nothing very fancy. I shouldn't even call it a search engine. A simple search functionality, wherein I want to enter, let's assume a bunch of keywords. I want to say, let's say, machine space learning, right? Amongst all these documents, I want to return all the documents which contain machine learning. How do we solve it? Right? How do I, again, let's assume this is my query 1. Let's write multiple queries, right? Suppose my query 2 is, let's assume, let's write slightly something lengthier. So let's assume my next query is machine learning and artificial intelligence, right? Artificial intelligence. Okay, I'm just writing in short here. So this is my query 1, this is my query 2. So given this query, I want my function, let's assume I have a function. I want this function to return all the documents that contain machine learning. Again, this whole thing has to be there. And I want it to return all the documents which contain, again, sometimes you may not have all the keywords also, right? So think about how do you solve this. I'm leaving it slightly open-ended. Machine learning and artificial intelligence, I wanted to return all the documents which contain this. How do you tackle this? Any suggestions? Any suggestions? Regex on every file. Oh, cool. That's good. Okay, let's say, okay, good. Okay, so let's assume I have regex on all files. How much time does that take? Okay, so let's assume I have document 1, document 2, so on and so forth, some document n. Let's assume n is large, right? Obviously, in the real world, look at Google search, right? There are like billions of documents. Suppose my regular expression is, let's say, machine learning. Okay, let's assume this is my regular expression. If I have to search this regular expression in each of these documents, the time complexity will be crazy because this document can be extremely long, right? This document can be extremely long. There could be thousands of characters here. Again, the length of this is small, but again, each of these documents can be very long and the number of documents can be very large, right? Again, remember, I want to build a solution. Since the point came up, I want to build a solution wherein, okay, so where were we? Okay, I want to build a solution wherein I'm going to ask, like in Google, right? I'm going to ask, let's assume, many queries in an hour. Okay, the solution that I want to build here is, let's assume I ask 100 or 1000 queries per hour. 1000 queries per hour. This is also called as, okay, so companies like Google actually measure in QPS, which is queries per second, not even hour, right? But let's assume I have all these documents and I'm getting 1000 queries per hour, right? And I want to extract all the documents given any query wherever this is there. Now imagine building it using regular expressions. That's a good idea. But the moment you build it using regular expressions, the moment you do it using regular expressions, for each query, there are thousands of documents. Document length is crazy. So how do I do it now? Somebody says string methods. Yeah, whatever you do. I hope you got the context, right? If I have, let's say, 1000 queries per hour, 1000 QPH, 1000 queries per hour, and if I have, let's say, 1 million documents, you will require like a crazy large computer to do it, right? So regexes will not scale to this problem. While it's a good idea, regexes will work if the number of documents is small, and if the length of each document is small, and if the queries per hour is small, then it will work. But imagine if each document is a web page, large page, and I have millions of documents, and I get thousands of queries per hour. Then what do you do? Somebody says dictionaries. How do you use a dictionary here? How do you design a dictionary? Can somebody tell me what is the value? What is the key in the dictionary here, please? I've not read all the answers. Of course, it's impossible for me to read everything. Somebody says indexing. What indexing? Database indexing. What indexing? Because indexing is a very general term, right? There is indexing concept in database also. Indexing using sorting, right? Indexing using B plus trees. No, again, somebody says we want to maintain ranking of pages. We are not going to that level. That's the next level. I'm simplifying the problem, right? Of course, if you want to go into the search algorithms, that's a huge area onto itself. I'm only solving a small sub problem in the search, right? So that's a huge area. Why do you want to go to TF-IDF? Okay, you compute TF-IDF, then what do you do? Somebody says we want to convert it. Beautiful soup, jo bhi hai na? Beautiful soup also will do regex like stuff only. Somebody says bag of words and then search. Okay, how do you search? Some of you have suggested, guys, please don't jump to TF-IDF, right? Because key is machine learning, value is yes. Okay, so what? See, what do I want? What is my input output? Let's not forget that, right? My input is my key, my input is my search keywords. My input are my search keywords. My output is a list of documents. A list of documents that contain this search keyword. I don't care about the ordering. If you want to order them, that's a different problem. I don't care about the ordering. I only am saying, given a search keyword, just give me the list of documents. Again, grep is nothing but your regular expressions only, no? So it won't work. Grep also won't work. Indexing as key with dictionary. Okay. What is key? What is key? Again, some of you are suggesting dictionary, right? What is the key and what is the value in the dictionary? I didn't understand that. Oh, some of you are saying inverted indices. Again, what? Again, an inverted indices is also a dictionary, right? At the end of the day, it's a dictionary. It's a fancy dictionary, that's it. So imagine, again, I understand that inverted indices is the answer, but let's try to, instead of giving names, let's try to understand using the concepts that we already know. Because most people may not know inverted indices, right? Using dynamic programming. What do you do with dynamic programming, guys? If you tell me dynamic programming, I'll say what is the recursion, where is the overlapping subproblem. Somebody says locality sensitive hashing. Where did locality sensitive hashing come here? We are not finding nearest neighbors, no, here. Somebody says using graphs to store. Guys, I think you're going everywhere. Okay, let's answer the question very clearly. Okay, I think all of you are like going in like every direction possible, throwing everything at it. Okay, let's think of a very simple thing. Imagine dictionaries is one way of solving this problem. I'm not saying the only way. Let's assume dictionaries is one way of solving this problem. What do you store as the key? What do you store as the value? Key, words in the document, value, number of types present, number of types word. What is types word? Dictionary, unique words, value, list of documents. Simple, very good. Many of you have suggested this, so I can't give one person credit. Very simple, right? Look at this. My dictionary will be, my key is the word. Each word, individual words. This is one way. My value is basically a list or a set. Instead of list, I can also store it in set, no? I can also store it as set of documents which contain this word. So first, what do I do? Look at this. This is very important. First, what do? I go through each word. I go through for each document. First, I read each document. For each document, for each word in the document. Again, I'm just writing pseudocode. For each word, you enter, first you search if that word is present in the dictionary as a key. If it is present, go to the set of values, go to the values. Add this document, every document give it a number. Let's assume this is document DI. Just add it to this set. So what are you doing here? First you're pre-processing. Your whole text corpus. Corpus basically means your whole text data, right? Or the set of all the documents that you have. First you're pre-processing your whole corpus, right? Once you just do it for each document, for each word, just find that word. If that word is not present in the dictionary, create an entry and create a set of documents. So this will say for this word, let's assume there is a word machine. This word is present in document 1, document 6, document 12, so on and so forth, right? First, this is called pre-processing. This is the first stage. Then there is a second stage. In the second stage, you can say, given any query now. Suppose I'm given a query, which is machine learning, right? Machine learning. First, I'll search for machine, right? In my document, I'll search for machine. So when I search for machine, I'll use this as the key. I'll search in this dictionary. It will give me a bunch of documents. It will give me document 1, document 6, document 12. It will give me a set of documents. Then I'll search for learning. This will give me a set of documents, right? Now let's take the intersection of both these, because we want documents which contain both machine and learning. So this will give me a list of documents. Let's assume it gave me document 6 and document 12. One solution is return this as your result. Now the problem if you return this as your solution is, there is a problem. This is one way of doing it. The problem with doing it is, D6 could be a document which has machine blah blah blah, then intelligence in a different context. Machine and intelligence are not next to each other. So I'm not finding this phrase. What is a phrase? Phrase is basically a sequence of words. So this machine is there somewhere in this document. Let's assume document 6. Machine is there somewhere in the document. Learning is there somewhere in the document. But it's able to find this whole document. Cool. Not bad. This is a first cut solution. This is your first cut solution. This is your first cut solution. Again, this is very simple. You just write a function called preprocess, construct this dictionary. Second, you say query. Give these words, given this, find the set of all the documents in which machine is there, find the set of documents in which learning is there, take the intersection, return. But you could have this case also. So what do? Instead of just making your key, okay, that's a problem, right? So what do? So let's assume I have document 1. I have word 1, word 2, word 3, word 4, word 5, so on. So a document is basically a sequence of words, right? So what did we do till now? We said, let's take each word and let's create in our dictionary. In our dictionary, we said word 1, right? Word 1 corresponds, word 1 has document 1 and other documents in which word 1 is present. Then in our dictionary, we have word 2 and all the others that are present. This is the key, this is the value. Okay, let me write it instead of writing it in this notation. Okay, so this is the key, this is the value, right? This is the Python notation, right? Then word 3, sorry, not D2, D1, I'm sorry, D1. So it's present in D1 and other documents also. This is also present in D1 and other documents. So here your key is basically single individual words. Individual words in natural language processing are called as 1 grams, right? So again, we'll learn this when we learn NLP in future sessions. But instead of just using one word, why don't I also create 2 words? So what if my dictionary, in addition to containing only 1 words, it also contains word 1 space word 2 as my key. So these are called as 2 grams, right? These are called as 2 grams. So if my dictionary contains 1 grams, which basically means individual words with the values containing the document number, 2 grams, which means I'll take W1, W2 and I'll add D1 corresponding to it. I'll also take W2, W3, all pairs of sequential words. So W2 space W3, again, I'll make an entry. Obviously, when I do 2 grams, the size of the dictionary will become very large. Again, actual search engines, not just to do 1 grams and 2 grams, they do 3 grams, 4 grams, even 5 grams. So the size of the dictionary becomes very, 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 very large. When the size of the dictionary becomes large, okay, think of something like Google, right? The dictionary will be in terabytes or probably even larger, right? You cannot, I'm sure Google's dictionary will be more than terabytes. If this dictionary is too large, you can't store it in the RAM of a computer. You can't store it in the RAM of a single computer. Then what do? You take this dictionary, you store it in a distributed fashion in the RAM of multiple computers. That is what is called as distributed hash tables. Those are called as distributed hash tables or distributed dictionaries. Those of you who have heard of this term, again, if you're not, just wanted to give you a context here, right? So there is this very powerful open source tool called Redis. Distributed hash, sorry, not Redis, I'm sorry. What am I saying? This is called, what is it called? One second, I'll have to Google search, I forgot its name. There is a very powerful open source inverted index. Again, this is what is called as Lucene is one, but there's a better one now. Lucene is an old one. Come on. Applications, compression. Okay, there is a, one second. I can just go to Amazon AWS. AWS search. Cloud search. What does cloud search use? Apart from cloud search, there is one more service. Products. compute, containers, blockchain, analytics, feature services. Come on. I'm not getting it. It's called something. Elasticsearch. Yes, thank God. Yes, it's called Elasticsearch. So there is an open source tool called as Elasticsearch, right? Which very powerful tool. It's available on many cloud computing platforms like AWS, etc., which give you a very powerful way of constructing these distributed hash tables for search. Distributed hash tables for the search. Again, this type of data structure where you are taking the words and you are storing the documents in which the words are there. This special case of a dictionary is what is called as an inverted index. This is what is called as an inverted index. Search engines actually use a lot of inverted index, right? Again, the way to think about it is Elasticsearch is a distributed inverted index based system, right? There are also distributed hash tables. There is something called as Redis and Memcache, right? They're very powerful. They're very powerful distributed systems that can give you like a hash table but distribute across multiple computers. So Elasticsearch gives you inverted indices, while Redis and Memcache gives you a general purpose dictionary or a hash table which is distributed on multiple computers. Anyway, so that's I just wanted to connect the dots for you. Most importantly, I want you to build a simple system, nothing fancy. Okay, try to write code wherein you take some 10 documents, just copy the text from Wikipedia. Take some 10 Wikipedia articles, copy the text. So first you should write the pre-process. First you should have a dictionary D. Right? Oh, sorry, let me not write this notation. So you should have a dictionary D in which you're going to store the way I just mentioned key value pairs. You given a query, you want to search for this the way that I just explained. Try to do it with both 1 grams and 2 grams. This is not complex, given that we have seen how to process strings, given that we have seen some examples on how to use dictionaries. I think this is a good exercise. It's also very satisfying for you because you're doing something that is non-trivial. I understand this is non-trivial, but again, if you sit on it for a couple of hours, you should be able to do it, right? Sounds good. I think I've overshot by a few minutes. Yeah, thank you. Hey, Google BigQuery, yes. Just like Elasticsearch, Google has an internal tool called as Google BigQuery. Yes, that's true. Okay, folks, thank you very much. So next live session, just wanted to make that clear. I hope I have a slide. No, I don't have a slide. Okay. So the next live session is basics of Arduino programming from a machine learning perspective, right? So see you in the next live session. I'll make the announcement on YouTube. Okay. Thank you very much for joining in. Again, have a safe time. I hope everybody is staying safe. It's very important that all of you are safe, right? So please stay safe.